NEC Section 250.104b addresses bonding of piping systems and grounded building metalwork. It is often applicable in situations involving multiple occupancies served by a common metallic water line. The key aspect here is whether the common water line supplied by the utility is considered a grounding electrode. If the water line is metallic and provides a continuous path, it can serve as a grounding electrode system for each of the occupancies. NEC Section 250.104b specifically deals with the situation you described. It does not explicitly require each occupancy to have its own individual grounding electrode conductor when a metallically interconnected common grounding electrode, such as the water line, is used. In the scenario presented, each occupancy has its own underground copper water line, separately metered. The water meters are located underground in front of each occupancy. While the individual water lines do not connect metallically within the structures, the common water line serving the water meters is thought to be metallic. Given these conditions, NEC Section 250.104b likely can be applied. The common metallic water line provided by the utility acts as a grounding electrode system for each occupancy. The hot and cold water lines within each occupancy would likely be metallic. These lines must be connected to the service entrance conductor, which is likely grounded in each occupancy. The connection should also extend to the water meter. Considering the requirements of NEC Section 250.104b2, each occupancy is not necessarily required to have its own separate grounding electrode conductor, provided that the metallically interconnected common grounding electrode is present and properly utilized. However, certain conditions must be met for this to be compliant. Firstly, the common water line must be reliably metallic throughout its length to ensure effective grounding. Any non-metallic sections or couplings can compromise the grounding path and require additional measures. Secondly, the connection to the common water line must be made in accordance with NEC requirements. Typically, this involves using a bonding jumper of appropriate size to connect the service equipment grounding system to the water pipe. Thirdly, it's crucial to verify the continuity of the grounding path throughout the water line system. This can be done through visual inspection and electrical testing to ensure that the grounding connection is effective. Fourthly, local amendments or interpretations of the NEC may influence the application of these rules. Always consult with the local authority having jurisdiction, OJ, to ensure compliance with all applicable regulations. If there is any doubt about the integrity or suitability of the common water line as a grounding electrode, it is always prudent to install supplementary grounding electrodes, such as ground rods or ground plates. This provides an additional layer of protection and ensures a reliable grounding system for each occupancy. The NEC provides specific guidelines for the size and installation of grounding electrode conductors and bonding jumpers. These guidelines must be followed to ensure that the grounding system is effective and safe. For example, NEC Section 250.66 provides guidance on sizing the grounding electrode conductor based on the size of the service entrance conductors. NEC Section 250.104 provides guidance on bonding metal water piping systems. Grounding and bonding are critical for electrical safety. They help to minimize the risk of electric shock, prevent the buildup of static electricity, and provide a path for fault current to flow back to the source, allowing overcurrent protective devices to operate and clear a fault. Properly installed grounding and bonding systems are essential for protecting people and property from electrical hazards. Here's a breakdown of key considerations related to grounding electrode systems and bonding in multiple occupancy buildings. 1. Grounding electrode system requirements. The NEC specifies requirements for grounding electrode systems to ensure effective grounding of electrical systems. These requirements are outlined in NEC Article 250, Part Roman 3. The grounding electrode system typically consists of one or more grounding electrodes connected together to form a low-impedance path to earth. Common types of grounding electrodes include metal underground water pipes, concrete encased electrodes, e.g. U for grounds, ground rings, and ground rods for pipes. 2. Metal underground water pipe electrode. A metal underground water pipe is a commonly used grounding electrode. To qualify as a grounding electrode, the water pipe must be in direct contact with the earth for at least 10 feet. The water pipe must also be electrically continuous and free from any insulating sections or couplings. In multiple occupancy buildings, a common metallic water pipe can serve as a grounding electrode for multiple occupancies, provided that it meets the requirements of the NEC. 3. Bonding of water piping systems. In addition to using the water pipe as a grounding electrode, the NEC also requires bonding of metal water piping systems to ensure electrical continuity and to minimize the risk of electric shock. Bonding involves connecting the water piping system to the electrical grounding system using bonding jumpers. The size of the bonding jumpers is determined based on the size of the service entrance conductors, as specified in NEC Table 250.102. 4. Grounding electrode conductor size. The grounding electrode conductor connects the grounding electrode to the service equipment grounding system. The size of the grounding electrode conductor is determined based on the size of the service entrance conductors, as specified in NEC Table 250.66. For example, if the service entrance conductors are 4/0 American wire gauge copper or 250 kilocircular mils aluminum, the grounding electrode conductor must be at least 2 American wire gauge copper or 4 American wire gauge aluminum. 5. Common grounding electrode for multiple occupancies. In multiple occupancy buildings, a common grounding electrode can be used for multiple occupancies provided that it meets the requirements of the NEC. The grounding electrode conductor from each occupancy must be connected to the common grounding electrode. The size of the common grounding electrode conductor must be based on the size of the largest service entrance conductors serving any of the occupancies. 6. Supplementary grounding electrodes. While a common metallic water pipe can serve as a grounding electrode, it is often recommended to install supplementary grounding electrodes to provide additional grounding protection. Supplementary grounding electrodes can include ground rods, ground plates, or concrete encased electrodes. The NEC requires that supplementary grounding electrodes be bonded together to form a common grounding electrode system. 7. Isolation of water piping systems. In some cases, water piping systems may be isolated from each other due to the use of non-metallic piping or fittings. In such cases, each isolated water piping system must be bonded separately to the electrical grounding system. This ensures that each water piping system is effectively grounded and that there is no risk of electric shock. 8. Local amendments and interpretations. Local amendments or interpretations of the NEC may influence the application of these rules. Always consult with the local authority having jurisdiction, OJ, to ensure compliance with all applicable regulations. 9. Inspection and testing. Regular inspection and testing of grounding and bonding systems are essential to ensure their effectiveness. Visual inspections can identify any damaged or deteriorated components. Electrical testing can verify the continuity of grounding and bonding connections. 10. Documentation. Proper documentation of grounding and bonding systems is essential for maintenance and troubleshooting purposes. Documentation should include details of the grounding electrode system, bonding connections, grounding electrode conductor size, and any supplementary grounding electrodes. In summary, grounding electrode systems and bonding are critical for electrical safety in multiple occupancy buildings. By following the requirements of the NEC and consulting with qualified electrical professionals, it is possible to ensure that electrical systems are effectively grounded and bonded, minimizing the risk of electric shock and protecting people and property from electrical hazards. Understanding the specific requirements for grounding electrode systems, bonding, and common grounding electrodes is essential for compliance with the NEC. Consulting with qualified electrical professionals and the local authority having jurisdiction, OJ, is always recommended to ensure that electrical systems are installed and maintained in accordance with all applicable codes and regulations. The NEC specifies minimum requirements for electrical installations. It is always prudent to exceed these minimum requirements to enhance electrical safety and reliability. For example, using larger grounding electrode conductors or installing supplementary grounding electrodes can improve the effectiveness of the grounding system. Regular maintenance and inspection of grounding and bonding systems are essential to ensure their continued effectiveness. Damaged or deteriorated components should be repaired or replaced promptly. Changes to the building or electrical system may require modifications to the grounding and bonding system. Any such modification should be performed by qualified electrical professionals and in accordance with the NEC. Grounding and bonding are complex subjects. Staying informed about the latest developments and best practices is essential for electrical professionals. Attending continuing education courses and participating in industry organizations can help electrical professionals stay up to date on the latest grounding and bonding techniques. It's important to consider that the interpretation and application of the NEC can vary depending on local jurisdictions and the specific circumstances of the installation. Therefore, consulting with qualified electrical professionals and the local AHA is crucial to ensure compliance with all applicable codes and regulations. In the situation described, the fact that the water lines do not connect metallically within the structures is less critical than the presence of the common metallic water line serving all the occupancies. As long as that common water line is effectively grounded and properly connected to each occupancy's service equipment, it can serve as the primary grounding electrode. However, it's essential to verify the integrity and continuity of the common water line to ensure that it provides a reliable grounding path. If there are any doubts about its suitability, supplementary grounding electrodes should be installed. Furthermore, the bonding of the water piping system within each occupancy is still crucial to ensure electrical safety. All metallic water pipes within each occupancy should be bonded to the electrical grounding system to minimize the risk of electric shock. The grounding electrode conductor should be sized according to NEC Table 250.66 based on the size of the service entrance conductors. The bonding jumper should be sized according to NEC Table 250.102 also based on the size of the service entrance conductors.